Goeiemiddag graad 12's. Ons gaan vandag aan met calculus en die deel wat ons die tempo van verandering noem, rate of change. Die gradiënt van 'n funksie is gee die tempo van verandering van daai funksie aan by spesifieke punte. So if you get the gradient of a specific the gradient at a specific point of on a function, that will be the rate of change at that specific point. So as ons gaan kyk na die funksie ft, dan kan ons die tempo van verandering bepaal waar TA is deur die afgeleide te kry van die funksie by die punt A. If you've got a function ft at the point A, you can determine the rate of change of that function at that specific x value A. Wanneer die tempo van verandering positief is dit 'n stygende funksie, and when the rate of change is negative, the function is decreasing. Kom ons kyk na die funksie ft, en hierdie funksie wys die tempo van verandering van die volume van water binne in 'n watertank. This is a function that shows the volume of water within a water tank, and this water tank is the input and output is connected and to that water tank, and this equation is the volume at specific times in hours. That's being measured in liters of the water in that water tank. So the first question that's being asked, hoeveel water was oorspronklik in die tank? How much water was originally in the tank? So what we're going to do, we're going to substitute the time with 0, because that will be the water originally in the tank. So if you do the substitution of that, you'll get 0 plus 6, and that's going to give you 6 liters was originally in the tank. Next question, watter tempo sal die volume water in die tank verander na presies 6 ure? At which rate will the volume of the water change in the tank after precisely 6 hours? So we recognize the rate, the word rate of tempo, so ons gaan dadelik die afgeleide kry. As ons die afgeleide kry, is dit minus 2t plus 24, and then you can substitute any given time after 6 hours. It's going to be the volume is increasing at 12 liters per hour. Okay. So now if we ask after 15 hours and we substitute 15, you get a negative answer. As ons 'n negatiewe antwoord kry, hierso kry ons nou gelyk aan minus 6 liter per uur. Dit beteken, nou daal die volume teen 6 liter per uur. In die handboek sê hy, dit neem toe, dis nie waar nie, die volume daal, want die tempo van verandering is negatief, daar's 'n foutjie. Okay, the next question will then be, after how many hours will there be 50 liters in the tank? So, na hoeveel ure sal daar 50 liter in die tank wees? So, ek gaan 50 in die gewone volume formule in substitusie doen. And then I'm going to get it equals to 0, and I'm going to factorize to determine after how many hours will there be 50 liters in the tank. So let's do that. So now we can take everything to this side of the equals to. If you bring that, it becomes negative, so my antwoord gaan dan wees plus 42 plus 44, not 42, and if you factorize that, it's going to give you 2t minus 2t minus 22. So, t is gelyk aan 2 of 22, that means after 2 hours there was 50 liters in the tank, en dan weer na 22 uur was daar weer 50 liter in die tank. Laaste vraag, nou hoeveel ure sal die volume van die water afneem teen 'n tempo van 12 liter per uur? So as ons kyk na die woord tempo, and the question in English, after how many hours will the volume of the water decrease at a rate of 12 liters per hour? Afneem, so dis minus 12 liter per uur, is waarvan hulle praat, and that will be the value of the rate of change. So dit gaan die antwoord wees van die afgeleide. So die afgeleide is minus 2t plus 24. So as ons dit gaan uitwerk en daai kom oor na daai kant toe, of hierdie na hierdie kant toe, dan sit 2t minus 36 is gelyk aan 0. So t is dan gelyk aan 18. So after 18 hours, the volume will decrease at 12 liters per hour. Goed. Kom ons gaan kyk dan, nou hoe weet ek wanneer het ek 'n maksimum en wanneer het ek 'n minimum op 'n funksie? If you get the derivative, remember, and the answer of the derivative is 0, we know we are at a stationary point, a turning point. Maar hoe gaan ons weet daardie minimum of daai 'n minimum of 'n maksimum draaipunt is? Ons weet dit deur te gaan kyk na die punte net kleiner as die draaipunt se x-waarde. If the derivative there is smaller than 0 and after the turning point is greater than 0, then we know it's a minimum turning point. As my afgeleide se waardes voor die x-waarde van die draaipunt groter is as 0 en daarna kleiner is as 0, dan weet ons dit is 'n maksimum draaipunt. Dit is hoe ons dit bepaal. So kom ons gaan terug na hierdie voorbeeld toe en ons die volgende vraag is, nou hoeveel ure sal die volume van die water in die tank begin afneem? Nou hoeveel ure sal die water in die tank begin afneem? Meaning, the volume of the water in the tank increase after how many hours will it start decreasing? So ek wil weet, wat is die x-waarde by daai spesifieke draaipunt? En hoe sal ek dit doen? Ek gaan my afgeleide gelykstel aan 0. Waar is my afgeleide? Minus 2t plus 24 is gelyk aan 0. So then, if you determine your t, it's going to give you 12 hours. So na 12 ure gaan jou stygende funksie 'n draaipunt kry en dan weer begin afneem na 'n dalende funksie after 12 hours. Wat is die maksimum volume water in die tank? What's the maximum value of the water in the tank? Nou onthou, by jou draaipunt is dit die maksimum waarde van die volume in jou tank. So ek kan die 12 ure in my oorspronklike, dit is hoe ek my draaipunt moes kry. I get the derivative equals it to 0 and that gives me my x value of my turning point. Nou wil ek die volume hê by daai spesifieke draaipunt, so dis sy maksimum. So ek gaan 12 in my oorspronklike formule insit en wanneer ek dit doen, dan kry ek die volume waar die ure 12 is. And then, if you do substitution in the original formula, you're going to get the volume of water in the tank when it's on its maximum capacity. So that's going to be 150 liters if you substitute 12 into the place of T, sal jy 150 liter, dis die maksimum kapasiteit van die tank. Graad 12's, ons gaan daai toepassings oefen, ek sien vir julle môre weer.